everyone, good morning. Hope you are safe wherever you are. For everyone who is joining us today, welcome to IIDA Summit. And for everyone who is already with us since yesterday, welcome back to IIDA Summit Day 2. IIDA Summit is an initiative by the Architects Diary. I am Radha, Managing Editor at the Architects Diary and your host for today. IIDA aims to bring about a stern and architectural fraternity through insightful engagements with renowned and greatest minds in the field of architecture and design. Our sponsors for this event are Insulpro and Bromic Heating. We thank them for believing in our vision. You can know more about Insulpro and Bromic Heating from the domes which you can access through directly from lobby. Our state-of-the-art venue is designed by Manticore Designs. There are a lot of challenges at hand for architects throughout the world, mainly because of the way we are operating currently. Everything is rethought upon and has got on a different paradigm. We need to locate the crux of any challenge to be able to solve it or maybe give an attempt to change certain things in the architectural world. This year's theme, as you already know, is the foyer to future. Is the future in the hands of technological advancements? Where is the sustainability factor going? What is the role of an architect in the field, and where is it leading in 2040? All of these questions and many, many more are brewing in our minds, and through this event, you'll be able to address these questions as well as much needed refined perspective you'll be able to gain. So please note the next 6 points for the entire event. You can switch between Auditorium 1 and Auditorium 2 whenever you want. You can download the schedule for today from either of the auditoriums. During the last few minutes of any session end, you can send in your questions and we would ask the designer on your behalf for the same. Please open the screen on a laptop device for a better result. You can converse with each other from the network lounge when there are break sessions going on. Starting with our first speaker today. Our first speaker today is architect Aparna Anirudhan from Zyeta. Architect Aparna is the head of research at Zyeta and holds a master's degree in architectural research from the University of Bath. Through her role, she aims to be a catalyst in the dynamic process of design thinking by integrating the theory and practice of architecture, closely collaborating with data and analysis. She strongly believes in the power of design and its element to both amaze and delight, and its true potential to create humane work environments. These principles are reflected in her writing and the way she envisions a space. A bibliophile and a gourmand, she indulges her interest across her travels with her nose buried in a book. Moving on to her talk. What is she going to speak today? So, the recent and obvious changes in our climate in the world over have long been ignored and pushed aside with a dismissive shrug. But climate change looms large and dark over the future, as we all already are aware. A leap towards a brighter future lies in committing towards net zero emissions, or at the very least, carbon neutrality. A host of countries have recently pledged to reach net zero emissions in the coming years, with 2050 being the year of deliverance. Long term implications of the business of building and construction are plentiful, and focusing on reducing greenhouse gases through efficient practices would help reduce operational costs and help make the world a better place. Through this talk, she will explore and explain the steps towards net zero emissions and how certain alterations to the purpose of building and construction would bring us closer to the target of net zero emissions by 2050. We give the floor to Ms. Aparna. Welcome to IIDA Summit, Architect Aparna.
Thank you. Thank you, Radha, for that lovely introduction. Hello, I am Aparna, architect and head of research at Zyeta. A warm welcome to you all to the second day of the IIDA Virtual Summit 2021. Personally, for me, it was quite an engaging and exciting day one. And through my talk today, I hope to do justice to this two-day showcase of talent and knowledge. Before I start, I would like to thank IIDA for this opportunity to be presenting alongside some of the greats of the design fraternity. As Radha mentioned, any questions you may have, please jot them down in the viewers questions tab, and I will try to answer as much as possible at the end of the session. Let's begin. The latest research is clear. To avoid the worst climate impacts, global greenhouse gas emissions will need to drop significantly. With this target in mind, the UNFCCC, United Nations Climate Change Framework Convention, drafted the Paris Agreement in 2015. The Paris Agreement is a legally binding international treaty on climate change. Its goal to limit global warming to below 2, preferably to 1.5 degrees Celsius compared to pre-industrial levels. To achieve this long-term temperature goal, countries must aim to reach global peaking of greenhouse gas emissions as soon as possible to achieve a climate neutral world by mid-century. In other words, net zero in 2050. The Paris Agreement is a landmark in the multilateral climate change process because, for the first time, a binding agreement brings all nations into a common cause to undertake ambitious efforts to combat climate change and adapt to its side effects. Since its effect in 2015, the Paris Agreement has seen a rapidly growing number of national governments, local governments, and business leaders making commitments to reach net zero 2050. To date, over 50 countries have communicated such net zero targets, including the world's largest emitters such as China and US, with the US recently rejoining the treaty in 2020. The buildings and buildings construction sectors combined are responsible for one third of global final energy consumption and nearly 40% of total direct and indirect CO2 emissions. Energy related CO2 emissions from buildings have risen in recent years after flattening between 2013 and 2016. Direct and indirect emissions from electricity and commercial heat used in buildings rose to 10 gigatons of equivalent carbon dioxide in 2019, the highest level ever recorded. Several factors have contributed to this rise. Energy demand for heating and cooling, with rising air conditioner ownership, extreme weather events, which ironically enough is due to the climate change. Extreme heat in many parts of the world was partially responsible for electricity demand growth in 2019, the second hottest year on record. Enormous emissions reduction potential remains untapped due to the continued use of fossil fuel based assets, especially for electricity and heating, for transport, for buildings heating and cooling, a lack of effective energy efficiency policies, and insufficient investment in sustainable systems. Long-term national low-emission strategies called for by the Paris Agreement can set out a vision for national transitions. These long-term objectives need to be linked to measurable short-term targets and policies. As you can see on the screen, these near-term milestones need to be achieved to for net zero 2050. By 2025, no new sales of fossil fuel boilers need to be have to be cut down. Renewable sources of energy need to be used. By 2030, the world needs a universal energy access with energy efficiency in place. All new buildings need to be zero carbon ready. By 2035, most appliances and cooling systems which are sold need to be the best in class with low maintenance and efficient systems. By 2040, 50%. By 2050, 85% of buildings need to be zero carbon ready. Achieving these will be a major boost to well-being and productivity in developing economies. The changes will affect multiple aspects of people's lives, from transport, heating, and cooking to urban planning and jobs. Uh, it is estimated that 55% of the cumulative emissions reductions in the pathway are linked to consumer choices such as purchasing an electrical vehicle, retrofitting a house with energy efficient technologies, or installing a heat pump. Behavioral changes also play a major part, particularly in advanced economies, such as replacing car trips with walking, cycling, or public transport, or foregoing a long haul flight, which also provides about 4% of the cumulative carbon emission reduction. India's target for 2030 is to cutting down carbon emissions intensity by 33 to 35% below 2005 levels, which is the baseline, and generating 40% of its electricity from non-fossil fuel sources by 2030. The countries cumulatively submit their plans for climate action, which this is known as the intended nationally determined contribution. In these NDCs, countries communicate actions they will take to reduce their GHG emissions in order to reach the goals of the Paris Agreement. India has taken the same goals and continue to work towards it, and will continue to cut down emissions by 2030. Zyta's 5-year plan. At Zyta, we look at creating efficient offices which focus on their financial sustainability, which is annual savings cost, optimized systems, it's the system's environmental impacts, and thereby its social impacts on communities. Our 5-year plan entails our goal to design workspaces that generate and harvest energy, and also help the organization in terms of revenue and retention, and hopefully we coincide with their own goal for energy efficiency. Energy efficiency is changing with digital technologies enabling greater control, optimization, and analytics. Digitalization describes a growing application of information and communications technology, short for which is ICT is the short form, across the economy. So this leads to increasing volumes of data, rapid progress in advanced analytics, and greater connectivity between humans, devices, and machines, including machine to machine, which is the ongoing progress towards artificial intelligence coming into our workplaces and into our communities. Uh, Digitalization's impact on the demand side is quite complex, but uh, but if managed carefully, the process of digitalization can actually be steered towards maximizing the benefits for energy system and minimizing the negative impacts. Data gathering technologies, such as which you see on the left, such as sensors and meters, collect data on energy use, uh, specifically like climate for energy use. This is then processed into useful information through analytics, and results in algorithms which are powered by artificial intelligence. This then is sent to devices such as automation and sensors and controls, which uh, which affects the data into physical changes in the ambient environment in the workplace. Some devices require human action to optimize energy use. For example, nowadays we know there is a smartphone app which can suggest an energy efficient route to work, or you can schedule meetings according to, and it can actually give you a route which would you know suggest an easier route to reach the workplace, maybe through public transport, or through or you can actually schedule a room very near to your residence, so that there is the cut down on commute is significantly higher. Digital technologies are already widely used in all energy end use sectors. More and more commercial buildings are equipped with smart appliances and intelligent energy management systems in the industry sector, including 3D printing, which is a standard practice. Now, many firms have taken up 3D printing, which is a sustainable way of of decreasing the usage of fossil fuel sources. Some of the smart building services that can be controlled through the Internet of Things are given below. Any business that is being operated inside a commercial building needs to collect, store, and analyze data for the advancement of the business. Usage of the Internet of Things, the IoT, is a competitive advantage, but it takes commercial building management one step further. This even helps in maximizing occupancy and increasing the occupants' comfort. Uh, we with When it comes to security and safety, we with the help of various types of sensors, beacons, and RFID tags, IoT can help in managing and utilizing the spaces appropriately. This is for real estate optimization, for meeting room scheduling. It can sort out data according to the occupancy of the room, occupancy of the building. Such kind of monitoring can help in better planning of the usage of the building, especially in the current pandemic situation. A staggered workforce would is actually an opportunity for us to be able to optimize our buildings according to how much the building, how much and how long the building would be occupied for. In safety and security, access control is the most important medium. So its connection to the internet has opened up new prospects. So facial recognition for enhanced security, detecting uh, uh, ease of vacating the building. Sorry, ease of vacating the building in terms of emergencies or natural disasters. Maintenance of building equipment like HVAC systems, electrical elevators, escalators can be made easy by IoT. Uh, all of these systems, all of these equipment, all of these controls, once they integrated with IoT, they actually encourage and enhance the optimization of a smart building. They actually would increase the chances of the occupants coming down to the workplace to use the workspace according to their comfort and according to how they would want to work wherever they are. All this is done via data and analytics, which was previously mentioned. This is one of our projects, Zyeta's project it is a platinum rated project from USGBC. It is located in Bangalore. Maxim Integrated is an American publicly traded company that designs, manufactures, and sells analog and mixed signal integrated circuits. One of the challenging input was to achieve green standards, and the project was approved for the platinum rated project. I will explain in detail one of the major factors for which we were awarded the platinum rating for this project. The natural lighting system was provided using optic fiber cables, which was powered by solar energy. How it works is optical fiber lighting can transmit natural light and make lighting based on the total reflection principle of the light and the fibers. This introduces the natural light from the natural source, the daylight, into the optical fiber. This is then redistributed to the interiors through the transmission of the optical fibers in turn, which is in line with the lighting needs of the lighting needs of the room. So, according to the diagram, you can see these are located on the roof. Each of the optical fibers are connected through a shaft, and in the fourth floor, which is the maximum floor, these have been used to light up the collab space in the interior. So this is where this is the lighting. This is which is actually powered by solar energy. So the optical fibers are all connected to this particular section of the floor. So this entirely is actually the placement of the lights are according to a grid. So it also works as a smart grid. So all the optical fibers are connected to a grid, and they eventually lead to lighting up the space in terms of whenever there is occupancy in that particular area. And there is it is energy efficient because obviously solar energy has been used. So, and also it cuts down on uh, the electricity demand of the building. Danaher Corporate. This is another project for Danaher Corporation. Uh, in its life sciences and diagnostic segment, Danaher is associated with Beckman Coulter, radiometer, biosystems, and more. The Beckman culture includes a lot of recent amenities encouraging discovery and innovation. It is set up in RMZ Eco World, Bangalore, and the focus of this project was on its HVAC system. We have used a HVAC system which is a thermofuser diffuser system. It is a VAV powered system. As you can see, each thermofuser diffuser has an adjustable built-in thermostat, creating an individual zone. So it creates a zone of its own. There are no. It's powered by a VAV system. It has thermal actuators to actually to transmit the ambient air across the different zones. So the system is actually you can be altered. The temperature of the zone can be altered via a thermostat, manual thermostat, which is in the room. So it provides according to the occupancy of the room. So if you are in the room and you want to use it for a particular period, so you can do it whenever you want. And it the main point, the main features of this would be there's a separate temperature for set points for VAV cooling and heating. The air distribution is throughout. It's optimized. There's no increased flow or increased throw in the room. There is even this temperature distribution, and most importantly, it is adaptive to the thermal comfort. It has low to no maintenance. At the 10-year warranty. And the main point of using this particular system in this project was that it awards 21 green lead rating points under the green building rating system. So how it does that is it creates a low energy approach by designing an all low pressure in all turned down individually zoned system. It provides individual temperature control and thermal comfort, which is the need of the hour. Produces high room air change effectiveness, and offers design opportunities for quiet operation, that which it is in terms of distractions at work due to the sound of the HVAC system. This is almost an innovative feature where it is completely quiet, and there's no the sound of motors or anything is not heard. And it also offers innovative benefits. The heating equipment market continues to be dominated by fossil fuel equipment and less efficient and conventional electrical heating technologies, which make up almost 80% of new sales. We have to make sure that these kind of measures can be undertaken to make sure the demand for heating and cooling of fossil fuels need to be cut down. Fuel in heating and hot water generation needs to be fossil fuel free. These are all coupled with behavioral changes. So once you understand that there is a significant increase in what you do in the increase of greenhouse gases and emissions, we have to take that step to moderate our use of these fossil fuel sources for fuel and heating. uh, the in terms of metering, the heating that is used for a space needs to be logged. They need to be analyzed, and they need to be used in analytics to make sure that it is at a set point, it is at a baseline, and it has to be made sure that it does not go beyond the baseline, and work towards having it below the actual baseline, like how in India has a baseline of 2005, and we are working towards 33 to 35. So it all comes up to us to actually change our behavior according to our usage, according to its moderation. Um, although there is in India, although there is a significant demand for heating, it is also balanced by an equal demand for renewable sources energy. So we have solar plants, we have hydroelectric electricity. So we do have a significant demand for the same. So it has to be balanced, and going along, it has to increase much more than the actual dependency on fossil fuels. So in demand response, the measures will have to be into allowing buildings to be flexible with their demand. But at the same time, all these need to be flexible in terms of using renewable energy rather than fossil fuel dependency. This is fundamental to allow the harness of renewable energy. Behavioral changes would be in participating in educational initiatives, which raise awareness and also increase enthusiasm for participation in voluntary schemes to reduce peak demand, and which should be a worthwhile endeavor. Zyeta collaborated with together to create an innovative design with an unmatchable aura of wellness throughout the space in its ORR campus. This is India's first pre-certified co-working space and has incorporated most of the well compliant elements in its design. The well is a section of the international IG IGW, IGBC. The design overall builds a state of the art shield of wellness and sanctity around their employees, maintaining a rock solid functional framework and a creative milieu that is built to stand the test of time. Especially in terms of keeping the employees at their at the comfort, at their meeting their needs of comfort. The design supports and promotes holistic wellness of the employees and members. So we have gone to this micro level of wellness and well-being of the employees through by utilizing the standards of well, by utilizing the concepts that make well. Uh, each element of the workspace, right from the raw materials to the furniture, uh, are 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 layered with positivity and well-being. Uh, this is a video which showcases how we have used the Unity AR. I'm sorry. Yeah, you guys can go through the video and I'll explain in detail. Space virtually through cutting-edge on-site AR technology. Remotely monitor ongoing progress in real time from anywhere in the world. As you can see, we have used the Unity AR software, which is a component of the Autodesk BIM 360. We have used this as a real-time design review and coordination solution that connects everyone involved with the project. So that would include the project managers, the designers, the architects, the construction, the vendors, everyone. So it is a very useful tool. It gives you actually a 1:1 model of the 1:1 scale of the entire model with details, including everything from the HVAC systems, the ducting, the flooring, the ceiling, the wall, everything is in one platform. And it is in current times especially, this kind of an interaction, this kind of immersive technology actually helps to for seamless communication between everyone involved in the project. So it is through this video you can see that it is an entire journey. It's from the construction to the post handover, to make sure that anything that we had proposed at the beginning and throughout and with any changes, they have been carefully and clearly integrated within the project at even post handover. This, as you can see, uh, the furniture has been integrated at at the time of designing. The ductings can be seen. If there are any snacks, they can be taken care at the same time. The it can be communicated to the person, to the designer, so that they can make sure that these snacks are solved and taken care of. Different categories can be chosen to see how effectively the placement of everything is according to what was proposed at at the beginning of the project and during. It has a breakdown of all the details. You want the kind of texture, the materials, anything that is used can be actually categorized and can actually be followed throughout the entire project through Unity Air. Yeah. So, as I had mentioned earlier, there is a social impact of sustainable communities. A sustainable environment needs to support all the basic needs of the end user in terms of shelter, comfort, health, and security by enhancing the individual and social well-being and overall the community well-being identity. Projects, they need to prioritize placemaking that expresses identity and territory. These are some of the design principles, design measures. We can provide high quality pedestrian public connections. So this is something that is integrated of a close community along with an urban setup. We can create provide spaces with a neurodiverse connection to nature. This is design spaces with adaptive thermal comfort standards. These kind of design measures and principles, at a micro level, they actually contribute to energy efficiency, because user behavior is very integral for us to set an energy efficient future, energy efficient goal for the organization and for all of us involved with design. This is one of our biggest career milestones. Our collaboration with Together has yielded us the award of the world's first health and safety rated co-working space by Well. Uh, the design, which was this comes at a time when the pandemic was at its, at its peak. We made sure that the employees safety and security was taken care of from the base level. The workplace meets and exceeds all criteria regarding health and well-being. Some of the features include a purified air supply, again very much needed in the present scenario. It was below 50 AQI with optimum CO2 levels. Clean water supply fit with RO plus and UV filters. Healthy natural light supply, which is optimized use of sunlight and human centric lighting. Proper nourishment. We have a cafeteria equipped with with labels which indicate food that is used for nourishment and for the well-being. Acoustic standards are maintained with double gypsum partitions which are 135 thick, and guidelines for cleaning and maintenance are strictly followed. Provisions of mental health and wellness support through workshops and literature is also taken care of. Those initiatives have been taken care, and creating a thermal comfort through suitable thermostat settings and optimum comfort levels also has been maintained throughout the building. And especially when it comes to a community building, creating a social impact through a community, we have made sure that this entire space integrates and gives a communal vibe to anyone who occupies this space. one of the major aspects and something that could actually be an integral part is financial sustainability of the project. uh, we at Zyta use daylight and solar analysis for making sure that spaces are designed alongside the zoning patterns, the peripheral zones, to make sure that the sunlight, the natural daylight, and natural light is used as much as possible. The heating and the heat thermal analysis actually helps us in making sure that certain zones that do not require that much of heating and can be optimized by proper cooling can are placed in those zones. Furniture is regulated, as placement of furniture is regulated via that circadian, as much as possible, circadian system of lighting is used. All these actually cumulatively they reflect on the annual savings of a build of an organization. They would be significantly higher. The savings would be much higher when compared to a baseline. So there's always a baseline. There's always a fact of an old versus a building which when integrated with efficient energy design systems and which is again powered by and connected through IoT, there is a significant increase in annual savings for the building and for the clients. So our the capital expense, which is the capex, would be capped, giving way to decide on more fixed assets such as lighting and thermal comfort. So these are fixed assets. So these when they are optimized, these when they are efficiently built and efficiently placed, these can actually increase the capital expenses rather than actually having to focus on operational expenses of the building. So this overall is actually increases the financial sustainability of the space, and all this is integrated with the policies of the organization as well. Coming to the carbon which is emitted and which is emitted through the operations of the building and the usage of materials. We have two carbon types in buildings. One is embodied carbon and one is operational carbon. Operational carbon refers to carbon dioxide which is emitted through the processes of heating, cooling, uh, which and lighting. So when a building is in operation, when a building is being used, there are certain values of carbon dioxide which is emitted due to those systems, due to the usage of those systems. Uh, 1 minute. Sorry. Typical energy sources for this purpose are electricity, and which electricity is fueled by fossil fuel burning, and natural gas, which actually increases the operational carbon of the building. The the all these the carbon part of these buildings, as I had shown in the first slide, contribute to almost uh, a 2.9 gigatons of carbon dioxide into the world. So buildings are a huge factor. Buildings are a huge factor when it comes to especially because we have our sole responsibility in making sure the buildings need to be efficiently built so that they don't emit the carbon dioxide, which will eventually lead to drastic climate changes. Embodied carbon refers to the locking of the carbon when during the extraction, manufacture, and transport of building materials. So, if you have to manufacture something for a particular material for a building construction, that the tapping of that material from its raw materials for it to be manufactured in the industry, the process of it being transported to the site, and the process of it being uh, built into the structure, this whole journey is an embodied carbon. This whole journey of that material emits enough carbon dioxide, which actually, if not taken care of, can actually contribute much higher to building carbon emissions. This is a visual representation of how buildings learn. What happens after they're built. Uh, the structure, which stays for 60 to 200 years, which is a long way to go. Concrete or steel structures have a high carbon footprints. It's one time, basically, when the building is constructed. So that again brings us to the fact of using buildings that can be retrofitted rather than actually constructing a building, because the structure in itself has concrete and steel, which are high. Which are big carbon footprints. All of these, we have a role in reducing the usage of these materials. The skin building envelopes have high embodied carbon emissions. Services in the mechanical, electrical, and plumbing system, which I just covered, they are everything is understood, the mechanism, everything is understood, but the kind of carbon emissions it is actually very significant, and it stays for 5 to 30 years. So there's 30 years worth of the amount of embodied carbon from these actually, it increases as the building gets older. The space planning, space layouts, internal walls, materials all increase the building's carbon footprint. Stuff as in anything that is used to for aesthetic purpose. If it's not does not have a capped carbon neutral value, again, they all contribute to an overall carbon emissions factor. And the site is obviously forever. They do not generate carbon emissions, but if a site is used as it is, with plants and with fauna and flora, uh, they'll be able to sequester the carbon to a level that will not be harmful to us. But we have seen that for constructing anything, or the first thing that we do is we cut down all the trees, we cut down all the biodiversity, which actually alters the cycle of that entire site. So all these are factors that lead to the increase in embodied carbon of buildings, and as I said, they are significant, and they really need to be used in moderation. uh, It is anticipated that embodied carbon will be responsible for 72% of the carbon emissions associated with global new construction between now and 2030. 2030 is a goal for India. So, uh, product, material, transport, construction, maintenance, and replacement, end of life disposal uh, of uh, of the materials, this contributes to 45%. So we have to these are the areas of focus, these are the areas that we need to focus on, which will actually reduce embodied carbon. So unlike operational carbon emissions, which can be reduced uh, you know over uh, over the years with efficient building management systems, and as I mentioned, the sensors and integration of automation. Embodied carbon is actually starts from the very beginning. It starts even before we actually think of managing a building with systems. So it starts from that level. We have to make sure that the materials, anything that is used for the whole building approaches need to be focused on. These all these actually contribute the respective percentages to that building. So these are the areas of focus, these are the uses that we will have to focus on, these are the uses that we have to cut down, to make sure that we, as designers, and as uh, we do not contribute to the emissions which is prevalent over the world now. This is something that is integrated in the LEED V4 rating system. It's called the life cycle assessment of interiors. So anything that is any material that we use, it has a certain life cycle. So this is the scientific method for quantifying the embodied carbon of each material, right from the extraction for its manufacture, to the distribution, to its use, and at the end the disposal. So it's something, it's almost like a circular economy. Whatever, there is no waste, right? Uh, uh, Whatever we make has to be, whatever we use, whatever we see around us, all of them, they're not supposed to generate waste, because nature does not have a policy of it being, it being a waste. There is a cycle. So once you start something, whatever we do, it has to go back to whatever it was. So that is the same case of materials that we have to use. Anything that we use, and if it has to be manufactured, if it has to be constructed on site, it has to have the same cycle for it to be disposed properly, and so that the carbon which is emitted during its life cycle is actually properly, it's the negative impacts is put aside due to, because of its disposal. So the disposal actually balances the positive impacts and with the negative impacts. So this actually will encourage a uh, carbon neutral organization, a carbon neutral global standard. So all this is paired with an environmental declaration, which we see is on the rise. It becomes a fact sheet. So if you, for a material, uh, you'll have certain categories, you'll have certain ways, whether it is how it has been extracted, how the method of manufacturing that particular product, the way it has been brought to the site, all these, and how much it is used, how where it will be used, what is the longevity, what is the durability, what is the maintenance, all these will be sort of in a fact sheet, and this fact sheet will be the driver for us to actually know whether this material can be used or not. So this again entails user behavior. We have to cut down, we have to make sure that whatever material we use is actually a give back to nature. We are not going to be using something that we should not be using something that goes against nature. Embodied carbon works in such a way that everything that we use has a potential carbon emitting quality. So we have to be very mindful of the kind of materials we use when constructing or manufacturing, or the interiors that we plan for. This is These are whole building approaches. Embodied carbon, as I said, they are something that are, it's 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 before the operations begin of a building. So one major thing would be to use and repurpose existing buildings, because construction actually increases the emissions of carbon. So using or retrofitting already constructed buildings is a huge factor when it comes to reducing embodied carbon emissions. Uh, Using salvaged or recycled materials whenever possible to eliminate emissions associated with manufacturing new materials. We have so many examples of recycled plastic, recycled wood, rather than virgin materials such as steel and concrete. Recycled kind of recycled materials can be actually used for the interiors. Uh, a clear carbon targets need to be established before the beginning, so that this is where the fact sheet, the EPD and the LCA fact sheet actually comes into force. So when you use a material, you need to know that this is the carbon target, this is the carbon carbon emission value of that particular material, and you need to make sure that at the end of the construction, at the end of the retrofitting, you know that this is your target and you need to work towards that target. And then uh, any and this also entails all the parties involved, right? Because owners, occupants, everyone needs to be involved in this. The project, the consultants especially need to be uh, as a whole kind of a scenario. Everyone needs to be involved in making sure the targets are met. Um, we have optimizing for material efficiency, as in we specify higher grade material usage, and don't and making sure the materials that are used are not, whatever we propose should not be uh, overly like brought into sight. As in, if you order so much, it has to be so much, or it has to be lesser, but there should not be a wastage of it at site or anywhere in between. Choosing carbon sequestering materials, as I said, a site in itself, when it is left with its flora and fauna, actually absorbs the carbon, and that essentially is a huge factor for us to uh, leave the site as it is, if especially if it is thriving with the biodiversity. Designing for durability, obviously, when anything that you design, any material that you use has to be durable over the long term. It has to collectively, if it is to be retrofitted, if a space has to be retrofitted, if a building has to be retrofitted with savage materials, with carbon absorbing materials, all of these will essentially lead to the point of it being durable over long term. Some more approaches are maximizing structural efficiency. So, optimum, what do I say? We have to achieve maximum structural efficiency in the terms of, that has to be lesser snags, that has to be lesser room for error when it comes to using the kind of materials. As I said, when when you choose materials, it has to be to the right level. It has to be balanced. Anything, there should not be any waste at the site, or there should not be any waste during its manufacture, during its product life. So, uh, which in turn actually contributes to it being durable. uh, we have to choose the right materials for our climate. So there are India has several zones which are segregated according to the climate. So according to the local resource, according to the climate that is there, we'll have to make sure that the materials that we choose are are in line with the climate of the zone. Uh, so this would be taking into consideration the heat and moisture and humidity level of the space. So the materials need to be, probably, if for example, if you have to use bamboo, we can use recycled bamboo uh, uh, wherever there are, the heating of the space is too much. We can use recycled bamboo. We can use it in ceilings. We can use it for the furniture. So those kind of materials need to be carefully picked and chosen for the space. We can use low emissions transportation. So this is part of the embodied carbon. This is where the transport of the final product is brought to site. So during this transportation, during this commute of the from the manufacturing unit to the site, the transportation that we use can actually be low emissions. They can be sent through, probably, electrical vehicles, as an example. And yeah, that can be logged and made sure that it, as a long term, it satisfies the carbon neutral targets. Limiting carbon intensive materials, this is again an overall uh, the fact sheet actually will help you in choosing those kind of materials. And a lower carbon alternative, so anything that is recycled, except for steel and concrete, or vinyl, anything other than these virgin materials, they all contribute to the lessening of the carbon emission rate. They are all alternatives. They are all lower carbon alternatives. This is a carbon neutral material board. For flooring, we have reclaimed hardwood, which is, it is reused. This is from cut down trees, which is wood that is not being polished or altered outside. They can be recycled to use at for various purposes. We have recycled rubber, which is from the from the sap that actually is found in trees. So this there's actually sap which is found in the rubber trees, but this is the sap that actually is ignored, which is actually left. So that actually can be used for to make recycled rubber. It is all made from rubber tires too. So tires can be recycled for rubber, recycled rubber. Flooring. Recycled glass again is from broken pieces of glasses. They are recycled. They are put together. They are integrated. They are mixed with colors. They have all of these materials have a low maintenance. Uh, they are fire retardants, and they actually, aesthetically pleasing too. So in usage of these can be moderate to high use. And as I said, all of these are low carbon alternatives for interiors. Jute in ceilings, we have biolaminate. We have stone wool, which is also has acoustical properties. We have the wall for wall. We have a lime wash, which is, an alternative to cement based mixtures, and suitable for any kind of surface. And then we have micro cement, which is a type of a joint free finish that's super easy to clean. Instead of, gravel and everything, we can use the very little waste is generated because of that, and once applied, there are no volatile emissions. So all of these have low to zero VOC emissions nowadays. Some So these are 3D printed products. These are a few products made from recycled sawdust. This is by Forest, California. They are a 3D printing uh, uh, company. This is a 3D lamp made from recycled plastic. So these are all carbon intensive products in its lifetime, but once they're recycled, they give way to such beautiful props and beautiful products that we can use anywhere in our interiors, and they are are zero carbon, low carbon alternatives to what we actually use in for our interiors. We cannot ignore the effect of the pandemic on our in the construction industry. Uh, it has derailed several industries off track, and how at a sub level it has created opportunities for us, for the design fraternity. But against the backdrop of already slowing energy efficiency, the COVID-19 crisis adds a new layer of certainty. Firstly, delayed investments in energy efficient systems has increased behavioral change. There were incentives provided for energy efficient usages in our homes, in commercial buildings. So because of the delayed investments in the economic scenario of these energy efficiency systems, there has been a change. There has been a behavior change into actually using these products, using these systems in our buildings. uh, the government policy response is also very muted. it is very slow, very slow. As if we have to achieve a target of net zero in 2050, the current government policy response is actually very slow, and it is actually, and with the COVID-19 pandemic is actually derailed, has actually slowed down that the progress that we had between 2003 and 2015. All of these need to be addressed. All of these need to be addressed under, if not a pandemic, for us, for India, or for all of us to actually achieve at the end the net zero. All of these need to be incorporated, all of these need to be taken care of. Investments need to be properly segregated according to the sectors. They need to make sure that all of these sectors, all of the organizations under the sectors need to have environmental policies which adhere to the UN SDGs, Sustainable Development Goals. We have our behaviors, everyone's behaviors, the moderation, the kind of usage that we have, that we the usage of these materials, of the usage of these systems, they need to be changed. They need to make We need to make sure that the way we see it, the way we see our future should be uh, coupled with how we use these materials. It is for the future. It is for us, for the generations to come. So we have to learn from our mistakes. And the thing is, we cannot take small steps. We need to take leaps forward to actually achieve that target. All of this, along with the government, needs to come together for this. So this is where everybody needs to be on board. The occupiers of the building, the investors who invest in the building, the developers, the supply chain of the material, of the entire journey of the construction of the thing, and binding them all together is our designers. So the design fraternity and everyone needs to be on board, along with the government policies, to make sure that uh, carbon emissions need to be cut down. They need to be targeted. Anything that you build, anything that you construct, anything that you retrofit needs to have a at least a low carbon target at the end. All of these all of these what do I say all of these come under a sustainability team, right? So it starts at the top with the commitment made by the leaders to enact change. For others, it's just gaining momentum. But every organization goes along a different path, and we have to make sure whichever path that is, the target should be a carbon neutral target. And sustainability needs to be an investment on its own. It needs to be an independent unit on its own. It has to be equally integrated with both strategic and operational business units. We all, cumulatively, occupiers, the investors, developers, will have to push harder. And as Ms. Suhasini had mentioned yesterday, this is a huge responsibility on our shoulders, and the impact of how we design, how much we curb our temptation to use those materials which running after aesthetically pleasing elements needs to be curbed. It needs to be environmental. We need to be environmentally conscious in whatever decision we make in terms of construction and designing. So all this needs to, what do I say? It's to make the world a eco-friendly and a better world, right? We all need to be the change. We all need to make workplaces of the future uh, which are efficient, which have longevity, and at the same time is uh, is efficient in terms of energy utilization and power saving. And 2050 is the year of deliverance. Be the change. Thank you.
Thank you so much. Thank you so much, Architect Apana. It was a great, detailed presentation on what you gave, and I guess it solved a lot of, ideas which we had for carbon emission. So there are certain questions from the audience, which we would request you to answer. A
Okay.
couple of questions. Yeah, so with how Texas came up with their first 3D printing housing, and then IIT Madras also, had a prototype
Yeah.
currently recently in India. So,
Yeah.
is the future like truly sustainable with 3D printing technology overboard, or like what are your views on it?
A 3D printing is only a very small sector of building construction, but it is an integral part if it is enforced as it is has been enforced by these certain companies. If we make sure that whatever we do can actually be 3D printed, there is the certain setback of it being manufactured with additives, right? But as I had shown, the company called Forest, it actually uses recycled sawdust to make those products. So if we can find those kind of carbon neutral kind of materials which can be recycled, such as plastic, glass, all these which are recyclable, that's the whole point. It has to start from the very beginning. If you're going to use a material, it has to have a high recyclability rate. So if you use that material, if you use wood, it obviously you can recycle it into various things, right? So if that material can actually be used to for 3D printing, well and good, but it is an integral part, but a very small part, I would say. There are a lot of other factors that come into play, and those factors also need to be taken care of. So 3D printing along goes hand in hand with our behavioral change also. The acceptance is very important when it comes to anything, any kind of software for sustainability. I can't hear you, Radha.
So, yeah, can you hear me now?
Yeah, yeah. Thank
Yeah. So the second question from one of the audience member is, what is the role of smart building services, and about the pros and cons of smart building services.
Yeah, so a smart building, as I had covered, it actually integrates the Internet of Things. So anything that we do, the kind of sensors, the kind of systems, the kind of uh, 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 the occupancy, everything can be evaluated through the IoT integration. So everything depends on data. The data is fed into this into the systems. The data is fed into automation systems, and all of that help us in making the building smart. So it starts with the building management system, wherein uh, the each of the product, each of the system that is used is actually connected to the overall IoT system. So if you're using especially now with a staggered workforce, when someone comes to occupy a space, and you're using only around, what do I say, 30% of the total building footprint, you're using only 30%. So a smart building, when integrated with IoT, when integrated with automation sensors, can actually uh, generate energy and power only for the 30% that is occupied. That is a smart building. When compared to a regular building, uh, which would actually not have these kind of systems or anything, the annual savings, the power usage of that particular system due to heating, cooling, due to ventilation, all will substantially increase, because it is not optimized to for that only the 30% occupancy, right? So in a smart building, that 30% usage will be the only 30%, will be the only percentage that is calculated at the end. So the annual savings actually round up to that particular uh, occupancy of that building. So a smart building is actually very efficient in terms of savings and power utilization.
So, like, there are a lot of pros, compared to cons, it seems.
Yes, as compared to the cons of a regular building without the integration of IoT. But the thing is, a smart building has a lot more. So there is utilization of space, the systems, the lighting, HVAC, safety, security. All those are an integral part of the smart building. All of these are connected. Humans and machines, machine to machine, everything is integrated. When compared to a regular building, the savings, the optimizations, the overall benefit of a smart building cannot be ignored.
For sure, for sure. That is true. So another, the question from one of the audience members is that does smart city concept work in India? Because see, smart cities are, concept of smart cities has been incorporated since a long time on, various parts of the world. So how does it work in India, the smart city concept? Your views on it?
Yeah. So again, everything involved for a smart city is actually important. So a smart city comes under an urban design, right? So when nowadays every urban space is designed according for it to be for example, there is an eco district. So an eco district has these kind of it's a higher alternative, a higher not alternative, a higher grade of a smart city. So it involves everything within its own walls. So as I said, when you want to utilize a space for a meeting, there is a building which is, you might have a meeting space in the same building that you are staying residing in, or it might be within walkable, or it might be within cycling distance, right? So those, everything needs to be optimized. So a smart city actually takes care of the kind of commute transit. It has its own heating and cooling provisions. It is generated, the electricity, the power is all generated by renewable sources. The parks, green hubs, green cover will be more. So all of these go hand in hand, and this is where all of us need play a role. Investors, occupiers, consultants, designers, all of them need to go hand in hand when building a smart city. So as far as India is concerned, 2030 is the target for reducing carbon emissions. So, a smart city and multiple cities across the different states would actually contribute to that target. Would actually push us faster and stronger towards that target of achieving the 30 to 33% of carbon emission reduction. So smart cities are a good alternative, but they need to be eco districts rather than, you know, it has to be an integration of everything, biodiversity as well as smart building integration.
Yeah, so smaller fragments need to be, be successful in these terms in order to make a larger picture
Yeah,
very much
larger
successful.
picture,
Yeah,
yes. The
for
atoms
sure.
make up a molecule, so the
Yeah,
smaller
yeah,
energy efficient molecule atoms will make up a bigger eco district of a molecule. So it has to actually reflect towards all the states.
for sure. And the last question from our audience is, which are potential smart materials in construction industry towards 2050? Like potential trends in materials in carbon emission 2050 to zero net zero carbon emission 2050. You told.
Okay. Smart, they're asking about. Okay, yeah. Anything that has a recyclable value, anything that is a product of a recycled material, and anything that actually has a low maintenance, are all come under smart materials, because it is a smart decision to use this material. So it's actually collectively a smart material. Uh, right now, we have as I had shown, we have something called cork, we have jute, we have particle boards, and we have these are some of the materials that are currently in use. We at Zyeta also have used certain materials that actually uh, are they encourage the sustainability of the spaces through both through the impact of it in the space, through financial to budget provisions also, low budget provisions also, and also because we also have a rise in these products being manufactured. We have these companies that are coming up with these because they are becoming more and more environmentally conscious. So we have more of these companies that manufacture and sell these products. So there is also that education, that awareness of those materials. So we the materials that I mentioned, these are available for now, and these are actually actually help us the drive towards being smart about choosing the right kind of carbon neutral materials.
Yes, that was, the questions we covered from the audiences. Thank you so much, Miss
Thank
Aparna.
you.
It was a great, great session and a very insightful one indeed. Thank you so
Thank you.
much for your presence.
Thank you for the opportunity. Thank you, everyone.
Yes.
Bye.